All right, now we're going to look at another example here. So now in this case we have three equations in three variables. So now we're going to solve this one, and this is another example of where we're going to get dependent equations, and then we'll talk more about that. Okay. Sometimes if you look at the equations you can see that one is a multiple of the other, especially if it's a whole number multiple. In this case you really can't tell. There's some kind of flags that might lead you to believe that it may be the case, but nothing that I would discuss here. So let's get this into matrix form, augmented matrix form. And so now we're going to have 1, -4, 7, 1, -4, 7, and then 14. And then we have -2, 9, -16. And then -31. And then we have 1, -7, 13. And then 23. Okay. Okay, so the first thing we would do is we're going to eliminate these two, make these 0. Okay. And so the way we're going to do that is we're going to take what? We're going to take negative row 1 plus row 3. So negative row 1 plus row 3, and then we're going to replace row 3. And then we're going to take 2 times row 1 plus row 2, and we're going to replace row 2. Okay? So if we come over here, the first row stays the same. These are going to become 0, so let's just put those zeros in. So if we do 2 times row 1 plus row 2, that's going to be 0, so that's going to be a -8 plus 9 is 1. 14 plus -16 is -2. And then 28 plus -31 is going to be -3. All right. So then we do the same thing for row 3. So it's going to be negative row 1 plus row 2. So again, we're going to get 0 here. And then we're going to get 4 plus a -7, which is -3. And then we get -7 plus 13, which is going to be 6. And then we get -14 plus 23, which is 9. And now you can see that we've got dependent, because you can see that this row is just 3 times this row, or if you want to say -3. So if we take -3 times row 2 and add it to row 3, all of these are going to become 0. Okay, so but let's do it. Okay, so now, and this is already a 1, right? So that's good. So we're going to take 3 times, we're going to take 3 times, I think I said -3, but it's just going to be 3. So 3 times row 2, row 2 plus row 3, and we're going to replace row 3. Okay, so 1 and 2 are going to stay the same, so that's going to be 1, -4, 7, and 14, and this will be 0, 1, -2, -3. And then the third row is just going to become zeros, right? 3 times this plus this is 0. 3 times 2 is negative 6 plus 6 is 0. And 3 times negative 3 is negative 9 plus 9 is 0. And so now, what does this tell us? It tells us that what? We actually can represent. So in other words, what this is saying is that there's redundancy in this system, right? Which means that we can actually represent the same solution set with 2 equations instead of 3, okay? And that's what this is saying. So the other thing too is this is telling us that one of the variables is free to be any real number. So it's a free variable, okay? So in this case here, we notice that both of these equations, these top 2 equations, have z in common, right? So we would say let z be the free variable, which means let z be anything, let any real number, okay? It's because we can write the top 2 equations in terms of z, okay? So let z be anything, right? So z is going to be any real number. And then we can write the second equation as what? This is going to be y minus 2z equals negative 3. Okay? Which means that we can write this as y equals 2 times z minus 3. And then x, let me do it over here. Okay. So x this equation can be written as x minus 4y plus 7z is equal to 14. But then we can substitute it, well, z here is free, but we can substitute in for y. Y is equal to 2z minus 3. So let's solve this for x first. So this is going to be x is equal to 4y minus 7z plus 14, which is then equal to 4 times y is equal to what? Now we're going to substitute 2z minus 3 minus 7z plus 14, and now we're going to simplify. So this is going to be 8z minus 12 minus 7z plus 14, and then we're going to combine like terms. So the 8z minus 7z gives us z, and the minus 12 and plus 14 gives us plus 2. So we know that x is equal to z plus 2, y is equal to 2z minus 3, and then z is free to be any real number. And so now, the thing is what does this tell us also? Keep in mind that this is representing 2 planes, right? These are 2 planes that are intersecting. And what do we know? When 2 planes intersect, they create a line, right? They intersect on a line or a curve. And so all of the points along that line or curve are in the solution set. And we know that there are infinitely many points on a curve or a line, right? So it makes sense that we would have this solution because this gives us an infinitely many solution sets. So one way to write this is as set notation, right? So this would be the triple. It's an ordered triple where we have x, y, and z, such that x is equal to z plus 2, comma, y is equal to 2z minus 3, comma, and then z is any real number. That's one way to write it. Or we can simply write it as a set with an ordered triple, and we could parameterize this, right? And we could say, okay, well, just use z as the parameter. So it'd be what? Z plus 2, comma, 2z minus 3, comma, z. And then we end it with the parenthesis. So here, it's in terms of z, right? Where z is any real number. Okay? Or in fact, what we could do is, just to make it even more accurate, is actually spell it out. So it would be an ordered triple such that z is any real number. Okay? So either way is fine. It's just the way you write it out. Just make sure you're clear on that. But that's it. Have a great day.